Hello, everyone. I hope you are all doing well. I just want to quickly cover OSI model and TCP IP model. Uh, I believe these two models, they are the core of the network. I'm saying this mainly because from the network layers, each one of them, we can get the type of the device that operates on that layer, the type of the protocol that operates on that layer, the type of data format that operate on that layer or each layer processes. And also we can get the type of the addresses that each layer uses to establish the communication in the network. So I believe the entire communication network, we can summarize it using the following layers, but I don't want the video to be too long, so I'll try to shorten my description of each layer. Thereafter, I will also show you the types of each data format that each layer processes so that communication can occur in the network. So I'm going to start with the OSI model. Then I'll go to TCP IP model. So in the beginning, when communication network was established, they had to establish how the network devices communicate. They had to establish different types of protocols that each layer can use to establish communication or process data from one layer to another layer. So this OSI model was used to establish that. So I'm going to start with a sentence that gives us the first letter that identifies each and every layer. This is just to make sure that you don't struggle when you want to remember all these layers when you are writing exam. So the sentence reads as follows. It's all people seem to need data protection. So from that sentence, each and every letter of the first, each and every first letter or on that sentence of the words, it gives you the first letter that can help you to remember the layer of each of this OSI model. It's all people seem to need data protection. So that sentence will help you to remember all the layers. So that being said, I'm going to start explaining from this physical layer. What happens? What types of devices do we get there? Then I go up. So the physical layer is the layer that allows network devices to join the network. Our end devices include computers, our cell phones, our desktop computers. So we normally use those end devices to join to the network. We normally use cables or Wi-Fi to connect to the network. So I will also give you the different types of each data type that we get on each layer as I go forward with my explanation. So on the physical layers, I've indicated that we get end devices, or this is the layer that allows end devices to join to the network. On the next layer, which is called data link layer, is the layer that expands the network. It allows our end devices to communicate with the network switch. So on this layer normally operates locally. So when I mean locally, in a network, we have two types of network. We have local area network and wider area network. So if you want to communicate internally within your company with end devices within your network, you can use this layer, mainly because it establishes network communication using MAC addresses. It uses a network switch to do that. Then we have network layer. Network layer is the layer that allows us to establish a network communication using IP addresses. There is a video that I've created that talks about how we create IP addresses. You can go and view that I named it Subnetting Made Easy by Dr. Topside E. Matosi. You can go and look that on YouTube also. So on this layer, it allows us to establish communication using IP addresses. So it allows us to talk to the remote network, or it allows us to talk with different networks. Then on transport layer, this is the layer that deals with end-to-end communication. So in this case, what they mean by that, this is the layer that helps us to determine or establish which type of a protocol it can use to transmit data, depending on the different type of traffic that we are transmitting. If you are transmitting real-time traffic, it means you're going to use UDP. Some they call it user data gram protocol that deals with connectionless oriented. So in simple terms, UDP deals with real-time traffic, like making a call. If you make a call, just know that you are using UDP protocol. If you are, let's say you want to try and access a specific website, that's non-real-time communication. They call it connection oriented. So you get response depending on whether the device which you want request from is working at the given period. So that's why they call it connection oriented. So that's where this is the layer, that's where the network chooses or the type of the protocol it can use depending on the type of the traffic you as the end user you are trying to transmit in the network. So we get two types of protocols there. TCP, we use it for non-real-time communication or non-real-time traffic. Then we use UDP for real-time traffic. Then we have session layer. Session layer helps us to separate the different sessions that we can have on our machine or on our end device. I'll just give you a typical example with opening different websites. If you can open multiple websites at the same time, where you are using a tab, where you can click new tab. So you can have your Gmail account, your Facebook account, your Twitter account, your Instagram account, and many other tabs that you can open. So in order to keep them separate and to allow you to start and end the specific session, we use session layer. So it helps us to start and end a specific session. It also helps us to keep our session separated. So we use session layer to achieve that. Then we have presentation layer. Previously, when they introduced the concept of network, you might have heard that computers only understand zeros and one. However, us as end users, we only understand numbers and letters. So in order to ensure that we can communicate with our network devices, there is a layer that formats the data into a way that devices understand and into a way that us as end users understand. So that happens on the presentation layer. So the presentation layer deals with data formatting into a way a computer understands and into a way us as people or end users understand. It also deals with data encryption. It helps to encrypt the data just to make sure that what is being transmitted over the network is protected from unauthorized users. Then we have the application layer. Application layer is the layer that deals with end users, us. It's the layer that allows us to read what we receive or to read what we send to other people. So it's the layer that deals with end users. So with that being said, I'll quickly jump to the TCP model. TCP model, what they've done with it, they've tried to combine or integrate different layers and then reduce the number of layers. As you have seen here on OSI model, we have 7 layers. With TCP IP model, we only have 4 layers. So they've combined the functions of each of the layers, then create one layer. So I'll start here again from the bottom. So what they've done, they've combined the functions of physical layer, and data link layer, then they call it network access layer. So it does the same job as the data link layer and physical layer. But in this case, they just decided to integrate the layers. So it will give you, it will give end users devices access to the network, then establish communication using MAC addresses. Then they changed the name of network layer to become internet layer. The reason behind this is because the internet is the one that allows you to communicate with different networks. So that's why they decided to call it internet layer instead of network layer. So it allows you to communicate with other network remotely. So that's why they call it internet layer. It's the layer that allows you to establish communication using IP addresses. Then transport layer, it was not changed, it's the same as on the OSI model. It does the same job, deals with end-to-end communication, where it selects which type of a protocol to use depending on the type of traffic that we are using. And I've indicated that for real-time traffic, we use UDP. Non-real-time traffic, we use TCP. Then application layer, what they've done, they've combined the functions of session layer, presentation layer, and application layer. And then they call this layer application layer. So it helps you to start and end communication. It helps to separate differentiation. It will deal with data formatting, data encryption. Then it deals directly with the end user. So they've combined the functions of the three layers to create one layer. So with that being said, I'm quickly going to go down a little bit and show you the type of protocol data units that each layer processes. So in this case, I'm going to use OSI model to do that. So with OSI model, each and every layer processes data in a way that layer understands. So that's what I'm going to cover here. So this is the physical layer. We're going to start with the physical layer and then we go up, as I've done when I was explaining the functions of those layers. So with physical layer, what happens in physical layer, as I've indicated, that we use cables or we use Wi-Fi, which we're going to use it for wireless connection. So in this case, the example is a cable. So as I've indicated, that computers only understand zeros and one. So our cable transmits electrical signal. The data which is being transmitted in a form of electrical signal is called bytes. This is the physical layer. This is the type of the frame that we get on physical layer, bytes. It's zeros and one. Thereafter, we move to data link layer. In data link layer, we have a protocol called Ethernet. It's the one that helps to transmit data from physical layer going upwards. If the data is coming from the application layer, it helps to take data from the network layer to the physical layer. So in this case, it uses Ethernet protocol to do that. So the type of the frame or the type of the protocol data units that we get on this layer, it's called frame. There we move to the network layer. The network layer I've indicated, or the internet layer, as I've indicated, that it uses IP addresses to establish communication. So this is an IP protocol. So in this type of a protocol, it uses packet to transmit data from one layer to another, or the type of the protocol data unit that we are going to get on this layer, it's called packet. This is the type of the data unit I'm referring to, packet. We get this on our network layer or internet layer. Then we move to transport layer. On transport layer, it's where I've indicated that we have two types of protocol. We have TCP and UDP. So in this example, this was non-real-time application. That's why you see TCP. So in this case, if it's TCP, the type of the protocol data unit that you'll get or that you'll have, it's called segment. This is the type of the packet or the type of the protocol data unit that you will get on transport layer. It is called segment. If you are using TCP, or if the type of the packet that you are transmitting on that time, it's non-real-time traffic. If it's real-time traffic, the protocol changes and becomes UDP. And the type of the frame, or the time of the protocol data unit that you're going to get, it's called data gram. So if you are using TCP, you're going to have segment. If it's UDP, you're going to have data gram. Then we go to the application layer. This is the one that deals directly with the end user. So here we get data. This is the data that us as end users, we can read and interpret. So I believe with what I've presented to you, it will help you to understand more, or the difference between OSI model and TCP. There is not much difference. The only difference that in TCP, they've reduced the number of layers, but it does the same functions as OSI model. And I've also given you the type of protocol data units that you'll get on each layer. So this is the correct format, or this is the correct logic, how data gets transmitted from one device to another. It's from this device in a form of bits, then it goes to, this is the physical layer in form of bits. In data link layer, it's called frame. In network layer or internet layer, it's called packet. In transport layer, depending on the type of the protocol, or depending on the type of the data you are transmitting, if it's real-time traffic or non-real-time traffic, it's called segment or datagram. On application layer, it's called data. So sometimes when you write, they might ask you to give them the correct data format, how data gets transmitted from one layer to another. So that also tells you that the communication, it's bottom to top. That's what they are also trying to tell you with this data format, how data get transmitted from one device to another. Thank you very much. Goodbye.